Welcome back, class. So this is the lecture number 9, and topic of discussion is application of EMF measurement or EMF of cell. As we had already completed the EMF calculation of EMF, the derivations of different category. So this is the lecture which is based on its application part. So in this particular section and in the next one, the importance of numerical is very, because most of the time the numerical part is always asked in the examination, especially for the EMF of the cell EMF. So let's talk about the application of EMF of cell. So the very first application is the uh, to find transport number of the ion. Transport number of ion. So this is the first application, to find out the transport number of ion. So as we know that we had already calculated the EMF by using transport number. I want to show you that uh, slide. So this is, if you remember, lecture number 3rd of this final unit, calculation of EMF of electrode concentration cell with transference. Okay, this is the electrolyte concentration cell with a transference. And in that particular discussion, what we calculated what, this is the equation. This is the E cell equation. T minus 0.059 log activity 2 upon activity 1. That means the activity of second and activity of first. So this was the final equation. So in this equation we have a transport number of an ion. So here we can use this equation in order to find out the transport number. So without any problem, what we will do that uh, for a cell with transference, okay, that was the cell with transference. So for a cell with transference, you can use any cell, but here important is transference. So what is that transference? H2 at 1 atmospheric pressure and HCl A1. This is what semi-permeable membrane, because we are talking about the transference. So this is not a salt bridge, this is the semi-permeable membrane. And HCl A2 with hydrogen 1 atmospheric pressure. So here the two concentration is different, so it is electrolyte concentration cell, and this semi-permeable membrane indicate that it is a transference cell. So it is basically example of electrolyte concentration cell with transference. Okay, because this cell is gives the value of um, transport number. So what is the EMF in that case? So in this case EMF, that means the E is T minus is the transport number of an ion, RT upon F, ln A2 upon A1. And if you uh, know, by knowing EMF of the cell, E, uh, activity A1 and A2, we can easily calculate what, we can find T minus. So this is a very simple application. Got it? Transport number, we have used transport number in only this case. Cell electrolyte concentration cell with a transference. So if you know the we can, if you find t minus by using the formula t plus t minus equals to 1, you can find the t minus plus also. So this is how you can find the transport number. This is how we can calculate the transport number. Okay, so that this is the first application. Now the second one. The second application is in the determination of valency of ion. In the determination of valency of ion. So this is another application, an important one, in the determination of valency of ion. Okay, so how the valency of ion will be calculated? So again we'll take example or EMF. So here we'll take the EMF of a concentration cell without transference. EMF of a concentration cell without transference. Okay, so for that we have a EMF equals to what? RT upon NF ln activity 2 upon this we had already calculated, this we had already completed, no? So I'm not going again in the detail. You can check my previous video lectures, so you'll find over there. Okay, so this is the EMF of a concentration cell without transference. So here if you know the value of EMF activity of A1 and A2, and this is the constant, R, T and F are the constant. This can be replaced by 0.0591 by putting the values. If you put the values, it will be given 0.0591 upon n log A2 upon A1, or in even you can write this E equals to 0.0591 upon n log C2 upon C1. C2 upon C1 is the concentration. Okay, it can be any concentration, molar, normal, whatever. Activity is again the same representation. So by knowing the values of activity A1, A2 and EMF, we can find out this n, because we want to find out the valency, and we know that the n is what? The indication of valency. So here we can calculate the valency also. Okay, so let's find out the valency. Let's take an example here. So example, in this case let's take an example. So example, here I am going to draw a cell, representation of cell, mercury Hg. Then we have n by 20. N by 20 is the concentration of what? Mercurous nitrate. Mercurous nitrate. So mercurous nitrate is mercurous nitrate, like Hg2Cl2. This will be what? Hg2 HgNO3. So mercurous nitrate, and you need to find write the molecular formula here. Okay, I'm writing the name. You need to write the molecular formula. Okay, so mercurous nitrate, very simple, like mercurous chloride. What is that? Hg2Cl2. So mercurous nitrate is what? Just think of that. I will tell you in that later. And as it is a without transference, so what we required here? We required a salt breeze, and here we can take a different concentration, because we are talking about the electrolyte concentration, so we require concentration of different. Okay, so let's take n by 2 here, and again the mercurous nitrate. Okay, and this is Hg. Got it? So here we have to find out the valency of mercurous ion, because mercury, that is always a problem here for the students, as if you go for the Hg2Cl2 or Hg Cl2, the value and the valency is always a challenge. So here we can find out the that valency. So now in this case we have this one is the activity 1 and this one is the activity 2, or this one is the concentration. You can write this A1, this is the A2. So you have given the values. Now nothing you have to do, only just go for the EMF. So I'm going to write that EMF you have given 0.0591 and we want to find out. Okay, and log, of course log, and here C A2. So A2 is what? N by 2. So N by 2 I can write this 1 by 2, and A1 is 1 by 10, sorry 20, 1 by 20. So this will give you 1 by 2 and 20 by 1. So this is giving 10, and log 10 is 1. So the value of log 10 is 1. So here all is what? E equals to 0.0591 upon n. Okay, because this whole value is 1 now. Now in order to find out the value of n, we require the EMF. So the EMF of this cell, EMF of the cell, this will give to you. Okay, if a numerical is asked, this value will given. So EMF of the cell is 0.0295 volt. This is the EMF. So you can put value of EMF here. So n equals to what? 0.0591 upon E, and this will give 0.0591. This is the value of EMF, 0.0295, and if you cancel, the value is 2. So because it is just double, 29 multiplied by 2, this will give you something like 58, and 0.5, this will give 1. So this is exactly 2. So now the valency of mercurous ion is 2. So here we can write the valency of mercurous ion is what? 2, and it should represented as it is valency 2. So Hg2 2 plus, this is very important. Okay, this is the representation, Hg2 2 plus, and the salt of its nitrate, salt of its nitrate is what? Hg2, and it has what? It has this Hg2 has 2 plus. Okay, so NO3 twice. Very important, this is very important. Hg2 is what? Representation of mercurous ion. Hg2 is the representation of mercurous ion. Hg2 2 plus, and this is NO3. So NO3 is represented by -1. Okay, so this is what the actually Hg2 2 plus and NO3 minus. So this cross will give you Hg2 and NO3 twice. This is the formula of mercurous nitrate. So this is what I asked to you, what is the formula of mercurous nitrate. Every time the students get confused that it is HgNO2 or Hg2NO2. Like in case of mercurous chloride also, what do you write? Hg2Cl2. So there again the N is what? +2. So this is one of the important application of EMF of the cell. I hope you will remember this, and especially The second one is very important, that is the determination of valency of ion, that is the N. So here I have given example to you, that is the mercurous ion. So thank you so much for your watching, and if you have any queries, any doubt, any comment, please write in the comment box. Okay, so thank you so much.